You ever stop and think about what a memory really is? We usually talk about it like it's a thing, right? Something you file away. But what if it's not a thing at all? What if it's a journey? A whole adventure that a piece of information takes through the incredible landscape of your brain. Well, today, we're going on that tour. We're going to follow a memory's entire life cycle, from the very beginning to the very end.
Here's a question for you. How is it that you can belt out every single word to a song you haven't heard in 20 years, but you have absolutely no idea where you put your keys this morning? Sound familiar? It's not a glitch in your system, I promise. It's actually a huge clue about how memory works, about the different paths that memories take. Some are just built for a quick trip, and others, well, they're in it for the long haul.
So first things first, let's just get rid of that old idea of a mental filing cabinet. It's a nice image, but it's just not how your brain works. It's so much more dynamic than that. Think of it as a living, breathing process. Information doesn't just get passively stored, it gets noticed, translated, strengthened, and then rebuilt. So let's trace that journey step by step.
Okay, so our grand tour of memory has three main stages. Think of it like a roadmap. First up is encoding. This is where you first take in the information. Next is storage, which is all about keeping that information safe and sound over time. And finally, you've got retrieval, the all-important step of actually finding and using that information later. For any memory to actually work, all three of these stages have to pull their weight.
Our journey kicks off at the very first stops for any piece of information heading into your brain. This is where every single memory, whether it lasts for a split second or an entire lifetime, gets its start. So every single thing you see, hear, or touch first lands here in what we call sensory memory. You can think of it like an incredibly high-def buffer. It holds a perfect, fleeting copy of what your senses just picked up, but only for an instant. We're talking less than a second for stuff you see, maybe just a few seconds for what you hear. It's that fast. But just think about it for a second. You are constantly bombarded with sights and sounds and feelings. There's no way your brain can process all of that. It would be total chaos. And that's where your attention comes in. It's like a bouncer at the door, acting as the ultimate gatekeeper. It decides what tiny fraction of all that sensory input is important enough to get a ticket to the next stage. Everything else, it just vanishes. So for the lucky few pieces of information that get past the bouncer, welcome to the waiting room. This is your short-term memory. A really good way to think about it is as your brain's countertop or your mental desktop. It's holding everything you are actively and consciously thinking about right now. But how much can this waiting room actually hold? Well, back in the 1950s, a psychologist named George Miller figured this out. He called it the magical number 7, plus or minus 2. What that means is, for most of us, our short-term memory can juggle about 5 to 9 separate items or chunks of information at any given time. That's it. And this waiting room, it has a really strict time limit. If you don't actively do something with the information in there, like repeating a phone number to yourself over and over, which is a process called rehearsal, it will just, poof, vanish in about 18 to 30 seconds. This is exactly why you forget someone's name 2 seconds after they've told it to you at a party. You didn't rehearse it, so it never got a chance to leave the waiting room. But what about the information that is important? The stuff that gets rehearsed and really thought about? Well, that information gets to graduate. It moves on to the final destination on our journey, the vast, sprawling, permanent library of your mind. And the difference between these two is just staggering. I mean, we go from a capacity of about 7 items to something that is, for all intents and purposes, unlimited. And we leap from a duration of mere seconds to, potentially, an entire lifetime. This transition from short-term to long-term memory is honestly one of the most incredible things your brain does. Now, this library isn't just one giant, messy room. It's got different sections, different collections. You've got your episodic memory, that's your autobiography, the story of your life. Then there's semantic memory, which is all about general knowledge, facts, like Paris is the capital of France. And then you've got procedural memory. That's for skills, like riding a bike or typing on a keyboard. It's the stuff you just do without even thinking about it. Okay, so if long-term memory is this massive, permanent library, then why on earth do we forget things? This is the central mystery, right? It turns out forgetting isn't just a failure of the system. It's a natural and sometimes even a necessary part of how our memory is designed to work. The guy who pioneered this whole field was named Hermann Ebbinghaus, and he was dedicated. To study memory in its purest form, he actually memorized thousands of lists of complete nonsense syllables, things like wid and zoff, and then he meticulously, painstakingly tracked how long it took him to forget them.
And what he discovered was, well, it's pretty shocking. He plotted his results on a graph that we now call the forgetting curve, and it shows this dramatic nosedive in how much we remember. We lose a huge chunk of new information within the very first hour, and then the rate of forgetting starts to slow down. The takeaway is pretty clear. Without a conscious effort to remember, most of what we learn just evaporates.
So here's the crucial idea. Forgetting happens because memory isn't like a video camera. We don't just replay the past. It's not reproductive, it's reconstructive. Every single time you remember something, you are actively rebuilding it from all these little traces of information scattered across your brain. And of course, during that reconstruction process, bits can get lost or changed or even mixed up with other stuff. But, and this is a big but, we are not helpless against this forgetting curve. Ebbinghaus himself actually figured out the key to fighting back. We can use specific strategies to make our memory traces way stronger and a heck of a lot more durable. First up, we can get around the limits of short-term memory by using a technique called chunking. A long string of 12 numbers like this is pretty much impossible to hold in your head at once. But if you group them into 3 meaningful chunks, 3 important years from history, suddenly it's super easy. You're not actually remembering more items, you're just making the items themselves bigger and smarter. Now, probably the most powerful way to defeat the forgetting curve is with something called spaced repetition. Instead of cramming all at once, you review the information at increasing intervals of time. Each time you pull that memory back up, you stop the forgetting process in its tracks and you send a powerful signal to your brain that says, hey, this is important, keep it. This forces that memory trace to get stronger and more permanent. And finally, maybe the best way to make sure a memory makes it safely to that permanent library is to encode it more deeply in the first place. Don't just repeat something. Really understand it. Connect it to things you already know. Create a wild, vivid mental picture of it. The more meaningful and distinctive you make the information at the start of its journey, the easier it's going to be to find it at the end. So, what does this all mean for us? It means a memory isn't a perfect snapshot of the past. It's an interpretation, a story that we rebuild in the present. And that really makes you wonder, doesn't it? Our entire sense of who we are is built on these memories, these reconstructed stories. So how much of who you are is based on what actually happened, and how much is based on the story you've chosen to remember?